I'm going to kind of go over some ideas from the probability test, and it's the Module 6 test. A lot of these problems are exactly the same, so I would definitely pay attention to them. So if we have a spinner right here, and we have six-sided die right here, all right, these two events are independent from one another, meaning the probability of this one doesn't affect the probability of the other one. Okay, so that's what it means to be independent events. If knowing whether or not one event has occurred does not change the probability that the other event will happen. Okay, so these are independent events. Okay, so the probability of a blue just on the spinner would be, since there are 8 total, there's 2 blues right here, so that would be 2 over 8. And always you want to reduce the fraction to 1/4. Now the probability of red or blue, that means because these are two mutually exclusive events, you would do the probability of red, which is 3/8, plus the probability of blue, which is 2/8, which gives you a total of 5/8. The probability of it not being blue, since there are 2 that are blue, there are 6 that are not. And we reduce that to 3/4. Now we have 2 events that are independent of each other. And when we do that, the multiplication rule for independent events is probability of A and B is equal to the probability of A times the probability of B. Okay? When they're not independent, we have to take out we subtract the probability of A and B occurring. Okay? And we'll get to that. So when the probability of that it's red and even, so the probability of red is 3/8. And the probability that there's 3 even numbers out of the 6 die, which is 3/6. And that turns into 9/48. And to reduce that, please make sure that you reduce it. It's 3/16. Okay. Now, probability of not red and not even. Well, not red means that there's 5/8. Right? And then again, not even would be odd, and there's 3 of those, 3/6. So that's 15/48. And that reduces to 5/16. Okay? So that takes you through basically 1 through 10 on your test. Now we have another one where you have basically, let's just pretend you have all these letters, each of them on a Scrabble piece, right? And you put the Scrabble pieces in a bag and you draw them out. Now when you do that, you take out and you leave that other piece out. So what that means is that they're no longer independent. So the probability of the second one changes. And let me show you how that works. So if we're trying to do the probability of an N and then a T, first of all, there are 12 letters, right? There are how many N's here? 1, 2, 3. So there's 3/12 of the N. Now, after I've taken out that one letter, there are 11 more left. And how many T's are there? There are 2 T's. So I'm going to multiply it by 2 over 11. So there's 2 out of the 11 now. So that gives me 6. Let me just reduce it. I'm sorry. I've got 1/22. Yeah. All right. Now let's try another one. Let's try probability of n, then an n, and then an I. Okay. So the probability of getting an n the first time around is 3/12. Then I go down and I only have, let's say I got that n. Now there's 11 and there's only 2 n's, so it's 2 times 11. 2 over 11, I'm sorry, times 2 over 11. And then an I, there's only one I, so that's 1 over 10. And when I multiply all those out, I end up getting 1 over 110. Okay, I'm just reducing the fraction as we get to it. So let's try the probability of n and not t. Okay, so the first thing we got is n. We know that is 3/12. And then we have 11 left over, right? And how many of those 11 are not t's? There's 9, right? Because there's 2 t's. So I'm going to multiply those together, and then I end up getting 9 over 44. Okay? So that should pretty much take you through the first page of the test. Okay? Now, for this one, we're going to talk about we've got experimental probability and theoretical probability. Okay? So for experimental probability, you use what you actually came up with out of the how many times that you did it. Theoretical probability is, let's look at this. So I'm going to go ahead and talk about it. So if I wanted to do the experimental probability, judging from the table for number 15 through 19, I said, okay, there was how many times I rolled a die 80 times, and out of 16 of those times I got a 4. So the probability of that is 16 over 80. Now, what we're saying is, well, what if I was trying to use this probability to determine how many I would get if I rolled the die 10 more times? So then I would take that experimental probability and multiply it by 10. And that would give me 2. Okay? But if you're working on a theoretical probability, on a die, to get a 4, a 1, 2, 3, or 4, or 5, or 6, it's only a 1/6 chance. All right? Now this is close to 1/6, but not quite. All right? And then, so if I multiply that by 10, I get 1.6 repeating. So this is based on the theoretical probability, and this is based on the experimental. Okay? Now, moving on to the next ones, I wanted to talk to you a little bit about mutually exclusive and what it means to be mutually exclusive and what it means to be independent. When they're mutually exclusive, they cannot happen at the same time. Okay? What that means is you can't be a freshman versus a senior at the same time. Okay? But you can be a senior and say 18 years old. So being a senior and 18 years old are not mutually exclusive. Okay? To be independent, one does not have the effect on the other. Okay? So each roll of a die and the probability of, say, getting a 4 on that die is the same each time. Okay, so they are independent events. Okay. So when they're not independent and you're trying to find out whether or not when you're doing a or statement for non-independent events, you're going to use instead of doing the just multiplying the two probabilities, you're going to do the probability of A plus the probability of B minus the probability of A and B. If they were independent events, going back, probability of A plus the probability of B is equal to the probability of A plus the probability of B minus the probability of A and B. So the likelihood of them occurring at the same time is not at all, okay, when they're independent, okay? So when we go to this next example, when we're talking about the fruit at the bottom of the page on the second page of the test, these are limes, by the way. Sorry, I tried to get cute correct. This is a lime. Okay, so let's see. Find the probability that you pick a fruit that is yellow or a banana. So the probability of yellow or a banana. Well, there are 1, 2, 3, 4, 5, 6. There's a total of 15 pieces, right? There's 6 fruits that are yellow. So there are 6 out of 15, right? And then I add the probability that it is a banana. So that's 1, 2, 3, 4, 5. So that's 5 out of 15. But then I have to take a probability that it's both yellow, that both events occur. So, and a banana. So I'm going to take away the probability of 6/15 times 5/15, which is going to give me 0.6. Okay? So use your calculator and make sure that you do that. Okay? Find a probability that you pick a fruit that is green or a lime. Well, so green or a lime. There's 4 green apples, okay, and 2 limes. So there's 6 out of 15 that are green, and there are 2 out of 15 that are a lime. And then you're going to take away the product of 6/15 and 2/15 away from that. And you're going to get 0.48. Okay? So that is a little bit more conditional probability. Not conditional, I shouldn't say. It's probability of non-independent events. Okay. Then we're moving on to factorials and talking to you a little bit about permutations and combinations. This is a factorial. Try how many ways. Please remember that doing this, you can do this on your calculator. You can also do this on Desmos very easily. And you can also do this with a formula. Okay? So I'm going to go ahead and do it with a formula so you guys can see what it looks like. But how many ways can gold, silver, bronze, and copper be awarded to 7 people? So we're trying to get, and notice that this is order, okay? So we're trying to figure out their order, like as far as first, second, third, and fourth. So order matters, so that is a permutation. So we're trying to get, calculate 7 total, right? The biggest number goes on the left, by the way. You're picking 4 people out of 7 possibilities. So that is equal to, this is your N and this is your R. So 7 factorial over 7 minus 4 factorial. So that's 7, 6, 5, 4, 3, 2, and 1. And this ends up being 3 factorial, so this is 3 times 2 times 1. So what happens is these can cancel out, and I just do this, and that ends up getting me 840. Okay. A combination is when the order doesn't matter. So in how many ways can 3 out of 7 students be chosen to serve on a committee? Now when you do this, combinations will most always be less than a permutation because order doesn't matter. So again, so we have 7 people total and 3 out of them is chosen. So that's equal to 7 factorial divided by 7 minus 3, so that's 4 factorial times 3 factorial. See why this is bigger? This is going to be a smaller number because we're dividing by a larger number. So I have 7, 6, 5, 4, 3, 2, and 1. And I'm going to just put 4 factorial here, 4 times 3 times 2 times 1. And then I'm going to do 3 times 2 times 1. So I go ahead, cancel these guys out, and I divide this. I have 3 times 2 right here is 6. So I can cancel out the 6. So 7 times 5 is 35. All right. Again, you could do this easily with your calculator. I gave you steps on doing that in one of the live lessons. For a Casio and this, and then also it's so easy on Desmos. So I definitely want to encourage you guys to do that. All right. So next one, let's see if there's anything else. Okay, the probability it snows on January 1st. Now these are exam questions or exam review questions. Okay. The probability it snows on January 1st is 0.315. What is the probability it will not snow? So the probability of, we're basically finding the complement of this. So we're doing 1 minus 0.315, and that'll give you the number. Okay? And then a florist has 12 different flowers in a bouquet. How many ways can a florist choose 3 flowers? Well, I'm going to set it up for you. That is a combination. So you're going to do choosing from 12 flowers. You're choosing 3. Okay? So that's 12 factorial divided by 12 minus 3 factorial. So that's 9 factorial times 3 factorial. Okay? So that's 12, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then I'm going to do 9, 8, 7, 6, 5, 4, 3, 2, 1. So these all cancel out. Okay. And then I divide it by 3 times 2. So 3 times 2 is 6, and if I divide that into 12, that's 2. So 2 times 10 is 20. See how they easily get down to a manageable number, but again, calculator is a great way to do it. Okay, so this would be, I would suggest you have one of these on your reviews. Okay, now I'm going to go ahead and do it for you. I would calculate each one separately and then multiply them together. So I have 4 times 3 times 2 times 1 divided by 2 times 1. So this equals 12. And then I've got 5 times 4 times 3 times 2 times 1 divided by 2 times 1. So I've got 9 times 3, so that's times 27. So 12 times 27, 14, 54, 2, so 4, 12, 324. Okay, try to do that in your calculator and see if you end up with the same result. Okay. Okay. The probability of getting a 1 or a prime on a die. So the probability of getting a 1 is 1/6. Now what are prime numbers? We've got 1, 3, 5, and 7. And okay, so these are 3 of those, right? So that would be plus 3 out of 6. So that's 4, 6, which is 2/3. So not bad. Okay. Again, those are exam review. 28 right-handed students in a class of 31. What's the probability a student will be left-handed? So that would be, if there's 28 right-handed, there's 3 left-handed, right? So it'd be 3 out of 31. Okay? Again, exam questions. You have a pop quiz with 3 true-false questions you're completing by guessing. So you have a 50% chance or 1 out of 2% chance, 1 out of 2 chance of getting it right. What is the probability that you get a perfect score? Well, the probability you get the first one right is 1/2. The probability you get the second one right is 1/2. And the probability you get the third one right is 1/2. Each one of those are independent and mutually exclusive, so that is 1/8. Okay, and I will go ahead and talk to you guys a little bit about statistics next time, because I know it is on your exam, but not during this lesson. So hopefully these are the probability questions that are on your exam review and also on your test. So I hope this is helpful. Please let me know what else I can do. Please do not forget your exam is at 4 o'clock tomorrow at Battlefield High School. Bring some ID. Hope to see you there. See you soon.